Hello everyone, how are you? My name is Megat Mamo. Today I will present you about electromagnetic radiation. At the end of this lesson, uh, students should be able to characterize the electromagnetic radiation in terms of wavelengths, frequency, and speed, and calculate the wavelengths and frequency of electromagnetic radiation. Most of the theories of electronic structure of an atom has been derived from the experiment that involved the nature of wave, light, and electromagnetic radiation. Electromagnetic radiation is the emission and transmission of energy in the form of electromagnetic waves. Waves can be defined as what series of vibrations that travel through a medium. For example, electromagnetic waves, sound waves, light waves, and water waves. All waves transfer energy from one place to another. Electromagnetic waves are waves that travel or propagate through a material medium like water and air, as well as through vacuum or empty space. Visible light, radio waves, ultraviolet light, X-rays, TV waves are common examples of electromagnetic waves. James Clerk Maxwell predicted the existence of electromagnetic waves. He assumed electric and magnetic field acting together produce electromagnetic radiation. The wave properties of electromagnetic radiation are described by four variables called frequency, wavelengths, speed, and amplitude. What is wavelengths? Wavelengths represented by what a Greek letter lambda. It is the distance between two consecutive crusts or troughs in a wave. This is a wave. This is a wave. The peak one represents what the crust, and the depths of this wave represents what trough, and the wavelength is the distance between what two consecutive crusts and troughs. For example, here, this is the wavelength, okay? Two consecutive crusts, this one and this one are what? The crust. The distance between these two consecutive crusts is known as what? Wavelengths, or the distance from the depths of the wave, that is what? The trough, to what? The next trough. This is the wavelengths of what? A wave. Frequency, it is denoted by what a Greek letter nu. It is the number of cycles of the wave that pass a given point per unit time. The unit of frequency is cycles per second, which is called Hertz. 1 Hertz equals to 1 cycles per second. This graph represents the relationship between wavelengths and frequency. Wavelengths and frequency are inversely related. When the wavelength increases, the frequency becomes what? Decreased. And when the wavelength decrease, the frequency becomes what? Increase. This graph indicates what? The wavelength is higher or longer, but the frequency is what? Lower. This one is a medium one, and the higher the frequency, the shorter the wavelengths. Amplitude of the wave, it is the height of the wave from 0 to crest, or 0 to what? Trough. It is a measure of the strength of the electric and magnetic field. It is related to the intensity of the radiation, which we perceive as brightness. This graph contains what? Two waves, the dark green one and the blue one. The blue one has what? Lower amplitude, and the dark green one has higher amplitude. The higher the amplitude, the brighter the rays, and the lower the amplitude, the dimmer the light. This one also indicates The higher the amplitude, the louder the sound, and the higher the energy. The lower the amplitude, the quieter the sound, the lower the energy. The speed of the wave is the distance traveled per unit time. It is a product of its frequency and wavelengths represented by lambda, frequency represented by watt nu, and the speed of light represented by watt c. A direct relationship between watt speed of light frequency and also watt wavelengths. For example, what is the wavelength of yellow sodium emission, which has a frequency of 5.09 times 10 to the power of 14 per second? Given we have frequency and the speed of light, and we are asked to calculate the wavelengths. Solution: apply the formula. The speed of light equals to lambda multiplied by frequency. Then lambda equals to 590 nanometer. The second example is what is the frequency of violet light with a wavelength of 408 nanometer. Given we have wavelengths 408 nanometer and the speed of light is 3 times 10 to the power of 8 meters per second, we are asked to find the frequency of the violet light. Solution: the speed of light equals to frequency multiplied by what wavelengths, then frequency equals to the speed of light divided by wavelengths, and the frequency of the violet light equals to 5.1 multiplied by 10 to the power of 14. Here there are part 2 questions. Is self-practice for you. Do it by yourself. This is the end of my presentation. Thank you for watching.